James Dyke is a lecturer in complex systems simulation at the University of Southampton and also co-chair of the multidisciplinary research group Sustainability Science at Southampton. James, what is sustainability science?
Well, it's a fundamentally multidisciplinary science. So it takes aspects from the social, the natural sciences, as well as engineering and medicine, because over the past decade or so, there's been an increasing realization that if we want to address some of the challenges that issues such as climate change, biodiversity loss, habitat destruction impose on us, and at the same time increase the well-being of people, then we need this fundamentally multidisciplinary, if not quite holistic approach.
I see. So what is it about the University of Southampton that makes it such a good place for research and teaching in sustainability science?
Well, I suppose there's three main reasons. The first is that we have a number of lead IPCC authors. They were leading some of the assessment activities for the Intergovernmental Panel on Climate Change, and they are, as well as modelling physical systems, the physical processes, they're all very strong on the social and the human responses to climate change. The second reason is that we've become an internationally recognised centre for the study of ecosystem services and poverty alleviation. So we're trying to understand how can we work with natural systems in order to ensure they continue to provide the sorts of services and the things that we need from the natural world that we otherwise take for granted. And the third reason is that we're very strong on the analysis of complex socio-ecological systems. I'm a tutor at the Institute for Complex Systems Simulation. It's a doctoral training centre, and we have just under 100 PhD students at the moment, and they analyse a whole range of complex systems, both natural and human. And it's that kind of integrated activities that I think brings a great deal of strength to our approach to sustainability science.
I see. So can you give me an example of how this complex multidisciplinary method works?
So just last week I was in Delhi attending a meeting with the Indian government and the World Bank, and what they're proposing is to develop an integrated decision support tool to help them guide developmental policies and practices in the Ganges Basin region. So there are over 400 million people that live in this region. It floods every year because of the monsoonal climate, and that displaces and sometimes even kills a very large number of people, produces an awful lot of economic damage, but it also represents a massive opportunity in terms of, let's say, hydropower. So what the government has typically in the past struggled with is how can you develop the Ganges, improve the water quality, improve people's quality of life who have to live in the region, and do that in an integrated and holistic manner, because we're not just interested in how much power can you generate, we're not just interested in trying to stabilise particular portions of the river, because as a river it's a fundamentally integrated system. So we're going to propose to produce this kind of integrated decision tool, which we've actually developed previously, or it's actually being developed as we speak, in the Bangladesh region. So the ESPA Deltas project is a multi-year, multi-institutional project, which is already demonstrating some of the benefits of this kind of integrated techniques that we're trying to develop here.
That's amazing. James Dyke, thank you very much.
It was a pleasure.